Welcome, curious minds, to the deep dive.
Great to be here.
Look around you. I mean, whether it's the accelerating pace of global problems, climate change, geopolitics,
Yeah, it's a lot.
or just the sheer overwhelming volume of information flooding our daily lives, there's this critical question looming larger than ever. How can human intellect possibly keep pace?
hmm
How do we, as individuals, as organizations, as a society, effectively navigate this labyrinth of information, make sense of its complexity, and find meaningful, impactful solutions?
It really does feel like we're hitting some kind of cognitive wall sometimes, doesn't it? It's a
Exact.
fundamental challenge, isn't it? The sheer scale of data and the interconnectedness of our global issues demand something more than just, working harder. We need to work smarter.
Right.
And that brings us, remarkably, back to the early 1960s.
Seems like a long time ago now.
It does, but it was an era that birthed a vision profoundly relevant to this very question we're wrestling with today. We're talking about the groundbreaking work of Douglas Engelbart.
Ah, Engelbart.
Specifically his revolutionary ideas on augmenting human intellect.
Augmenting human intellect. I mean, even the phrase itself sounds futuristic, right? Yet he was conceptualizing this way back, well before the personal computer was even a glimmer in anyone's eye.
Way before.
So, our deep dive today will explore Engelbart's foundational ideas. We're looking primarily at two remarkably prescient documents,
Mm.
his 1962 conceptual framework and the 1965 experiments, concepts, and possibilities reports. And the thing is, these aren't just dusty historical artifacts, fascinating relics from a bygone computing era.
Not at all. They are, in essence, prophetic blueprints. They serve as a foundational roadmap for the future of human-computer interaction and, crucially, for the effective use and design of artificial intelligence technologies that we're grappling with right now.
That AI connection is key, isn't it?
It's absolutely central. What's truly astonishing is how much of what Engelbart conceived as fundamental to human-machine symbiosis is only now, really, with the advent of sophisticated AI, becoming broadly understood, broadly achievable, and, frankly, absolutely essential.
So, our mission today is clear then. We're going to meticulously unpack these core concepts, really dig into what Engelbart was thinking,
Yeah, get under the hood a bit.
and then, most importantly, connect it directly to the cutting edge of AI development happening right now. So, you, our listener, you're going to gain some surprising, almost uncanny insights into the very nature of human-computer interaction.
We hope so.
This deep dive, it really offers you a shortcut to being truly well-informed on the philosophical underpinnings of our AI-driven future, helping you understand not just what AI can do, but why it matters in fundamentally augmenting and expanding our inherent capabilities.
Ready to jump in?
Let's unpack this. Okay,
Ah.
so to really grasp the essence of what Engelbart was proposing, we first need to define his core concept, augmenting human intellect.
Right, the foundational idea.
He defined it as increasing the capability of a man to approach a complex problem situation, to gain comprehension, to suit his particular needs, and to derive solutions to problems.
It sounds straightforward, almost deceptively simple when you put it like that.
It does, but the nuances he layered on top are absolutely key, aren't they?
They really are. When he spoke of increased capability, he wasn't just talking about doing the same things faster, like, a faster calculator. That wasn't the point.
Okay, so what else?
He elaborated that this entails achieving more rapid comprehension. Certainly speed is part of it, but also better comprehension, a deeper understanding.
Deeper, right?
And here's where it gets truly visionary for the 60s. The possibility of gaining useful comprehension in situations that previously were simply too complex for human minds to grasp unaided.
Wow. Tackling complexity itself.
Exactly. It's about speedier solutions, yes, but critically, better solutions.
Yeah.
And most profoundly, the possibility of finding solutions to problems that before seemed utterly insoluble.
Insoluble problems.
Think about that for a moment. Tackling challenges once deemed totally beyond the reach of human ingenuity. That's the incredibly high bar he set back then.
And he was very clear that this wasn't about isolated, clever tricks. This isn't just using a calculator or spell checker, right?
Precisely. He envisioned something far more organic and integrated. He talked about an integrated domain where hunches, cut and try, intangibles, and the human feel for a situation usefully coexist with powerful concepts, streamlined terminology and notation, sophisticated methods, and high-powered electronic aids.
So it's not just a toolkit you pull things out of.
No, it's a holistic ecosystem. It's where intuition and logic, the human element, and the machine capabilities work in seamless concert.
That's fascinating. And the relevance to AI today seems, well, unavoidable.
It's direct. What's fascinating here is how directly this foundational definition mirrors the highest aspirations for AI today. We're not just looking for AI to automate simple, repetitive tasks, although, sure, it can do that with incredible efficiency.
Right. That's the low-hanging fruit.
The true transformative ambition is for AI to genuinely enhance human cognitive abilities across incredibly complex professional domains. Think about diplomacy, scientific discovery, legal practice, executive decision-making.
High-stakes, complex areas.
Exactly. Engelbart's work highlights this long-standing goal of AI as a deep partner for human expansion and elevation, not merely a substitute or a replacement. It's about making us fundamentally better, more capable, more creative at what we do.
Okay, so building on that holistic view, he proposed a framework, right?
Yes.
The HLAM-T system.
The HLAM-T system.
Mm-hmm.
This acronym represents the 5 crucial components that, when integrated and properly considered, create this augmented intellectual capability. It was a systemic approach, really far ahead of its time.
So what does it stand for? HAMMT.
Okay, so H is for human, L is for language, A is for artifacts, the tools, M is methodology, how we work, and T is training.
Human, language, artifacts, methodology, training. Got it.
Engelbart viewed the entire system of a human and their augmentation means as a proper field of search for practical possibilities. This was revolutionary because it forced a systemic perspective. Too often, even today, we focus on just one shiny new piece of tech.
Like the latest AI model.
Exactly. And we expect it to magically solve everything. But Engelbart saw the whole picture, the interplay between all these components.
And the crucial insight here, which feels so relevant now, is that this system's performance is best improved by considering the whole as a set of interacting components rather than by considering the components in isolation.
That's the core principle. You can't just throw a powerful new AI model at a problem and expect miracles. You have to think about how it integrates with the human using their existing knowledge, their cognitive style.
How they talk about it, the language.
Right. The language they communicate in. The existing tools they use, which are today's digital artifacts and software platforms.
The established workflows, the methodologies.
Exactly. The methodologies they employ within their profession. And crucially, the training necessary to effectively leverage this new capability.
It seems obvious when you lay it out, but it's often overlooked.
It really is.
Yeah.
This holistic system approach is absolutely fundamental for effective AI integration. It pushes us to design AI tools not as standalone applications like some disconnected chatbot or a single-purpose analyzer, but as integral interacting components within a larger human AI system.
So they mesh properly.
Right, ensuring seamless interplay with human language, with existing software and hardware tools, our digital artifacts, with established professional methodologies, and with the necessary human training for adoption and mastery. This systems thinking is what prevents AI from becoming just another disconnected add-on that creates more friction or frustration than it actually solves.
It forces us to design for synergy.
Precisely. Where the sum is truly greater than the parts.
And that idea of synergy, where the whole is greater than the sum of its parts, brings us right to the heart of Engelbart's work, the intelligence amplifier concept.
Yes, the amplifier. He attributed the term to W. Ross Ashby, another pioneer. And it's critical to understand that the goal was always amplification, not replacement.
So making the human smarter, not making a machine to do the thinking for the human.
Exactly. Engelbart's view was that the goal is to amplify human intelligence by organizing intellectual capabilities into higher levels of synergistic structuring, rather than replacing or substituting human intellect.
Synergistic structuring. Can you unpack that a bit?
Sure. He defines synergistic structuring simply as when the organization of a group of elements produces an effect greater than the mere addition of their individual effects.
Okay.
Think of it like this. A band isn't just the sum of a guitarist, a drummer, and a singer, right? When they play together, well-rehearsed and attuned to each other, they create music, something far more powerful and emotionally impactful than any one of them could produce alone.
Right, that makes sense.
That's the synergy Engelbart envisioned between human and machine. In his HLAM-T system, the language, artifacts, methodology, and Tor, treating the LAM-T part act as the amplifier for the human's inherent intelligence. They are the instruments, the sheet music, the rehearsal studio, the practice, all amplifying the human's performance.
That principal amplification, not replacement, feels so important. But, looking at the current AI landscape with truly autonomous systems emerging, is there a risk we're losing sight of that original vision? Are we maybe leaning too much towards replacement sometimes?
That's a fantastic question, and it's a tension we absolutely need to grapple with. Engelbart's work serves as a really vital compass here. This core principle should guide the fundamental design philosophy of truly effective AI systems.
How so?
Well, AI should be built to augment and amplify human intelligence by creating synergistic partnerships, allowing humans to achieve intellectual feats beyond their unaided capabilities. When we design AI simply to do a task instead of a human, we miss the profound opportunity to enable humans to do more, to be smarter, to be more creative.
To engage in higher level thinking.
Exactly. By offloading the complex, iterative, maybe tedious clerk work to the machine. It's about designing a cognitive superpower suit, not just a robot substitute. The ultimate goal should be to make us smarter, more capable, and more creative, not redundant.
Okay, so to make this less abstract, Engelbart actually gave a really vivid example back in 62, right? The augmented architect.
Oh, it's truly prophetic. It's amazing to read today. He describes the architect at a working station with a large, 3 feet on a side, visual display screen. That's their main work surface.
Huge screen for the time.
Massive. And this screen is controlled by a computer, his clerk. That's what he called the system with which the architect communicates via small keyboard and various other devices. Imagine, in 1962, envisioning this huge interactive computer display, basically with a mouse and keyboard, a complete workflow environment for design.
The audacity.
Incredible.
And the workflow he outlines, it sounds incredibly dynamic, almost like what we have now in some advanced CAD systems.
It really does.
Yeah.
The architect tries out basic layouts, displaying detailed surveying data trees, utility lines, topography, all right there on the screen.
Instantly accessible.
Instantly. They can indicate points of interest with a pointer on the screen and instantly get distance and elevation from the clerk. They enter reference lines for their new structure and watch as excavations appear, revise itself slightly, and revise itself again on the screen in real time.
So it's not static drawing, it's fluid, iterative design.
Exactly. Responding to every command, every thought almost. Moving fluidly, the architect changes their view maybe from an overhead plan to a 3D rendering, then enters lists of items for later study, specifies structural details, a 6-inch slab floor, 12-inch concrete walls 8 feet high, and boom, the revised scene appears instantly. The structure takes shape right before their eyes.
And they can pull in external information too, right?
Yeah, that's key. They can interrupt the design flow to ask the clerk for a handbook or catalog information at any point, instantly pulling up building codes, material specs, whatever they need.
Integrated information retrieval.
Or right into the workflow. And they constantly recall, modify, or add to these interlinked working lists that represent their maturing thought process. It's like an externalized brain dump, an organized repository for ideas, constantly evolving.
And the capabilities went beyond just basic design, didn't they? He talked about advanced analysis.
He did. The architect could examine designs from literally any angle, a slice of the interior, from a specific point on the roadway. They could even check for sun glare.
Sun glare. In 1962,
Yeah. The clerk computes that one window would reflect strongly onto a nearby roadway during certain hours, flagging a potential problem long before construction.
that's simulation.
Pretty much. And they could perform functional analysis, tracking simulated daily activities of occupants to identify heavy traffic spots inside the building, or figuring out the peak drain on utilities.
So predictive modeling, environmental simulation, functional analysis, all baked into the design process.
Allowing for optimization and problem solving at a level that was just unthinkable back then.
And what about collaboration? Did he touch on that?
He did, and it's another area where he was way ahead. He envisioned that the entire design manual, not just the building design, but its associated thought structure of ideas, decisions, supporting data, could be stored on tape.
Okay, tape back then.
Right, tape back then. And explored by other architects, builders, or even clients. And crucially, these collaborators could then append special notes that are integrated into the design manual for his own or someone else's later benefit.
So a collaborative, version-controlled, shared knowledge environment.
Exactly, facilitating collective understanding and continuous improvement across a whole project team.
What's truly striking here, maybe the deeper insight, isn't just that he foresaw these tools, but that he understood the kind of partnership they'd form with human creativity.
Yes. He emphasized that the computer's capabilities extend far beyond just math. He said it could significantly benefit the human in non-mathematical processes of planning, organizing, studying. He saw the computer as a tool for manipulating and displaying information generally, for anyone who does his thinking with simplified concepts.
It wasn't just about the computer following commands.
No, it was about it anticipating, suggesting, integrating vast data sets in real time. This elevates AI from being just a fancy calculator to being a genuine co-designer, a cognitive partner.
The deep insight, then, is that the most powerful AI isn't just replacing a task, it's enabling a human to perform a fundamentally different, higher-level act of creation or problem-solving.
That's it, precisely. This detailed vision is a stunningly accurate prediction of modern AI-powered design tools, think generative design in CAD, or collaborative, real-time simulation platforms like NVIDIA Omniverse. Engelbart's clerk today is basically the AI assistant proactively feeding you feedback, suggesting optimizations based on countless variables and doing it all as you think and create.
It sets an incredibly high bar for future AI applications.
It really does. To be deeply embedded in professional workflows, augmenting human intuition and expertise, not just crunching numbers in the background. We're not just automating, we're fundamentally elevating the human role by offloading that complex, iterative clerk work.
Okay, so moving beyond the immediate practical applications, Engelbart also dug into something deeper, didn't he? The ways our tools actually shape our thinking, our language, maybe even our culture.
He did. It's a fascinating part of his framework. He traced the historical development of human intellectual capabilities through what he saw as four distinct stages.
4 stages of progress.
Yeah, he laid out a really compelling evolutionary path. He starts with stage one, concept manipulation. This is non-symbolic. His example was an Aborigine visualizing how to carry coffee without spilling it. It's direct mental engagement with concepts, no symbols involved.
Okay, pre-symbolic thought.
Then, a huge leap to stage two, symbol manipulation. This is where humans learn to represent concepts mentally with symbols, like using a single number for 27 sheep instead of having to picture each one.
Abstraction, that's huge.
A massive cognitive leap, abstracting reality into manageable symbols. Then stage three, manual, external, symbol manipulation.
Pencil and paper time.
Exactly. Tools like pencil and paper and eraser, straight edge, or compass come in. This was critical at externalized thinking, supplementing memory and visualization. It allowed for complex calculations, detailed records, intricate arguments. Engelbart noted it was deeply tied to the evolution of our modern way of thinking and communicating.
And then the 4th stage, the one he was focused on.
Right, stage four, automated external symbol manipulation. This is where the computer enters the picture.
His augmented system.
Yes. He described it as symbols with which the human represents the concepts he's manipulating can be arranged before his eyes, moved, stored, recalled, operated upon according to extremely complex rules, all in very rapid response to a minimum amount of information supplied by the human. He envisioned a computer coupled to a three-dimensional color display within which it could construct extremely sophisticated images.
Sounds like our modern computing environment, pretty much.
It really does, enabling fluid, intuitive interaction with complex data structures, letting us manipulate ideas with unprecedented speed and flexibility.
And this evolutionary view led him to his Neo-Horphian hypothesis, right? Which builds on the original Horphian idea.
Right. He first mentions the original Horphian hypothesis, which basically says that the worldview of a culture is limited by the structure of the language which that culture uses. Our language shapes what we can think, how we see reality.
Okay, language limits thought.
But Engelbart's extension is powerful. He proposed what he called the Neo-Horphian hypothesis. Both the language used by a culture and the capability for effective intellectual activity are directly affected during their evolution by the means by which individuals control the external manipulation of symbols.
Whoa. So it's not just language, it's the tools we use to manipulate symbols externally, writing, drawing, organizing, that shape our thinking and our language.
Exactly. The tools we use to externalize our thoughts don't just reflect our cognitive processes, they actively shape them. They influence how our language develops, what concepts we can even formulate, and the very sophistication of our intellectual activity. Our tools build our minds, in a way.
He had a great way of illustrating this, didn't he? The brick and pencil experiment. It sounds kind of funny.
It is a bit comical, but the point is deadly serious. He literally tried tying a pencil to a brick to see what writing would be like.
He actually did it.
Yep. Figure 2 in his report shows the results: messy, large handwriting. He found writing became slower and less precise, needing bigger characters, and it caused rapid fatigue. You start thinking, do I really need to write this down?
I can imagine.
His deduction from this seemingly absurd experiment was profound. If this brick pencil were the only way to write, record-keeping that enables the organization of commerce and government would probably have taken a form so different from what we know that our social structure would undoubtedly have evolved differently.
Wow, affecting society itself.
And the sheer effort would stifle experimentation with sophisticated new concepts, slowing learning, discouraging intellectual work. This would lead to radically different concepts, maybe simpler ones, and symbology that was much more economical of motion because every stroke would be a struggle.
It's a stark reminder that our tools are not neutral.
Not at all. They're deeply formative. Then he flips the script with a hypothetical table lookup device.
What was that?
Imagine a cheap, portable, high-speed device, like having an unabridged dictionary instantly available in 3 seconds flat.
Like Google on steroids in 1962.
Pretty much. He speculates on the impact. How would our vocabulary develop? How would our habits of exploring the intellectual domains of others shift? How might the sophistication of practical organization mature if each person can so quickly and easily look up applicable rules?
It changes everything.
Right. Frictionless access to information fundamentally changes how we learn, organize thoughts, interact with knowledge. If you could instantly look up any term or concept, your mental landscape expands dramatically.
So this section delivers a really profound insight for us today, especially thinking about AI.
Absolutely. The tools we use to manage and manipulate information don't just facilitate our work, they fundamentally shape our thinking and our language. Future AI, as the ultimate automated external symbol manipulation system, has this unprecedented power to reshape human cognition, communication, and problem solving on a global scale.
It's not just an efficiency boost, it's a potential mind shaper.
Exactly. And if we connect this to the bigger picture, effective AI applications should be designed not just to give us answers faster, but to intentionally foster new, more powerful ways of thinking by providing fluid, intuitive control over vast and complex information structures.
Like how large language models let us prototype ideas or brainstorm rapidly now.
Precisely. They're extending our cognitive reach, allowing us to form new connections, articulate thoughts in ways that would have been incredibly laborious or even impossible before. Which raises a huge question.
Yeah.
What new forms of intelligence, what new modes of thinking will emerge as we continue to co-evolve with these powerful cognitive tools? What does the human mind look like after decades of AI augmentation?
That's a big question. Now, one of the problems Engelbart was clearly trying to solve was information overload, a problem that feels incredibly relevant today.
Painfully relevant. But he wasn't the first. He actually revisited Vannevar Bush's seminal 1945 article, As We May Think. Bush identified this problem decades earlier. A true pioneer.
Bush saw this coming way back in '45.
He did. His observations were incredibly prescient. He wrote, "The investigator is staggered by the findings and conclusions of thousands of other workers. Truly significant attainments become lost in the mass of the inconsequential."
Sounds familiar.
Right. And Bush emphasized this was a larger matter than merely the extraction of data for the purposes of scientific research. It involves the entire process by which man profits by his inheritance of acquired knowledge. How do we actually use everything we collectively know?
That problem has only gotten worse, hasn't it?
Exponentially worse. We have more information than ever, but accessing and connecting the truly relevant bits remains a massive challenge for the unaided human mind.
So what was Bush's proposed solution? The MEMEX?
Yes, the MEMEX, a mechanized private file and library, conceived as an enlarged, intimate supplement to his memory. He
Okay.
described its physical form: a desk with slanting translucent screens for projecting information, a keyboard, buttons, levers for control, microfilm storage. Microfilm, yeah. And a plethora for direct entry of notes and photos. Basically, a personal knowledge workstation straight out of science fiction for the 1940s.
But the core idea wasn't the hardware, was it?
No, the real heart of the matter, according to Bush, was associative indexing.
Associative indexing.
Yeah.
Like hyperlinks.
Exactly like hyperlinks, decades before the web. He explained how a user building a trail could name it, then linked two items projected side by side on the screens with a single key tap, making them permanently joined. And crucially, any item can be joined into numerous trails.
Non-linear flexible linking.
A radical departure from rigid indexing like card catalogs. It mirrored the associative way our minds work, linking ideas based on context and relevance, not just alphabetical order or predefined categories.
He had an example for this too, right? The bow and arrow study.
He did. A user studying why the short Turkish bow was superior to the English longbow. They'd run through an encyclopedia, finds an interesting but sketchy article, leaves it projected. Next, in a history, he finds another pertinent item and ties the two together.
Building a knowledge trail.
Continually building this trail, inserting comments, branching off into side trails, maybe to textbooks on elasticity and tables of physical constants. Imagine the mental leaps this enabled, following threads of thought across disparate fields, building understanding from fragmented knowledge.
And these trails could be shared.
That was another key part.
Hmm.
These trails would not fade. Years later, the user could instantly recall a trail and photograph the whole trail out. Basically, export it and pass it to a friend for their own memex, where it could be integrated into their trails and augmented further.
Social knowledge building.
Exactly. Bush foresaw wholly new forms of encyclopedias, dynamic and interconnected, and the emergence of a new profession of trailblazers, those who find delight in the task of establishing useful trails through the enormous mass of the common record.
Trailblazers. That sounds incredibly like what AI is starting to do now.
Doesn't it? This vision directly prefigures modern knowledge graphs, semantic search, AI-powered recommendation systems. AI can serve as the ultimate trailblazer
How so?
by automatically identifying latent connections across vast data sets, summarizing complex info, presenting structured knowledge that lets users navigate these complex data landscapes with unprecedented ease.
Cutting through the noise.
Precisely. It directly combats information overload by making relevant information discoverable and interconnected. It enables us to collaboratively build and share dynamic knowledge structures in ways physical systems couldn't dream of. Think of AI curating research papers, connecting concepts across disciplines, suggesting related ideas in a design project.
It helps us profit from that inheritance of acquired knowledge, as Bush put it.
By making that inheritance navigable and truly actionable, AI takes the manual labor out of building the connections, letting our minds leap ahead to the insights.
Now, Engelbart himself, before his big computer vision, he had his own practical physical system, right? Using edge-notch cards.
He did, around the mid-20th century. He described it as a relatively simple electromechanical system using IBM card-sized edge-notchable cards. He was already trying to augment his own intellect manually.
What were these cards for?
He called them little kernels of data, thought, fact, consideration, concepts, ideas, worries, basically atomic units of thought. Each problem area had its own separate deck with a master card with descriptors for retrieval, using needles based on serial numbers or source references.
So like a personal analog hyperlinked knowledge system, a sort of DIY memex.
Pretty much a memex on a tabletop. He used it as a workspace for browsing ideas, making additions, building new sets of thought kernels for projects. He could quickly needle sort relevant cards for a write-up, keeping others separate, reducing tedious hand-searching or stacking in special category piles.
It must have helped.
It definitely improved his workflow, freed up some mental energy.
But that had limitations.
Big ones. And these limitations highlighted the very needs his future augmented systems would address. For instance, there was no convenient way to link these cards together so that the train of thought could later be recalled by extracting the ordered series of node cards.
No associative trails.
Exactly. The need for trails, like Bush's memex, became glaringly obvious to him through this hands-on experience. He could group them, but not link them in a narrative flow.
What other limitations?
The sheer physical effort and time spent manipulating the cards. He noted that the price I pay for this augmentation shows up in the time and energy involved in manipulating artifacts to manipulate symbols. This manual effort, sorting, restacking, searching it, limited his mental flow, his cognitive bandwidth.
His brain was busy managing the cards, not the ideas.
Right. He even recounted a memo writing experiment, trying to organize a research memo using the cards. He found it really difficult to deal with multiple levels of structure specs, organization, content, because the manual symbol manipulation was so laborious and inflexible. He sensed these possibilities for the flexible and powerful ways in which I could apply myself, if I but had the necessary means with which to manipulate symbol structures.
He knew there had to be a better way.
He felt it viscerally.
So this experience powerfully illustrates that practical human need for flexible, dynamic information structuring that old physical systems just couldn't provide.
Absolutely. And AI, with its ability to manipulate digital symbols rapidly, establish complex, nonlinear relationships, and automate tedious processes, directly addresses these long-standing limitations.
It shows the desire for intuitive, flexible information handling has been there for ages.
Exactly. And AI now provides the means to finally realize this very powerful methodology for everyday intellectual work. It's not just tech for tech's sake, it's the culmination of this long human quest for intellectual leverage, freeing our minds from the mechanics of managing information so we can focus on the meaning.
Okay, let's talk about the engine of progress itself. How did Engelbart see this augmentation actually leading to continuous improvement? He had this concept of a repertoire of process capabilities, right? Like a toolkit.
Yeah, exactly like a well-organized toolkit.
Mm.
He emphasized that the intellectual worker must know the capabilities of his tools and have good methods, strategies, and rules of thumb for making use of them. It's not just about having the tools, but knowing how to use them effectively together.
And he categorized these capabilities.
He did, into three types. Explicit human capabilities, things done entirely in the mind, like intuition or abstract reasoning. Explicit artifact capabilities, things done by tools without human intervention, like a computer doing a calculation. And composite capabilities, where human and artifact capabilities combine in a hierarchy.
And these capabilities build on each other.
Right. He illustrated how high-order processes, like writing prose, decompose into sub-processes like planning, composing, dictating, which themselves decompose further. The ultimate bottom of this hierarchy rests on basic human sensory mental motor abilities and the fundamental capabilities of the artifacts. It's a layered, modular view of how we work and think.
How does this relate to designing AI tools today?
Well, this framework provides a really practical blueprint. AI systems embody these powerful explicit artifact capabilities. By strategically combining them with our explicit human skills and processes, we can create powerful composite capabilities that are genuinely greater than the sum of their parts.
So it emphasizes the modularity of AI.
Exactly. Different AI components, maybe natural language processing, image recognition, a reasoning engine can be combined and orchestrated to form larger, more sophisticated problem-solving workflows that leverage both human and machine strengths. Think of it as building smarter tools, but crucially, also smarter ways of using those tools together. A coordinated symphony.
This modularity then leads to a really fascinating, almost profound concept Engelbart discussed, the reverberating chain and regenerative development.
Yes, this is powerful stuff. He suggested that a direct new innovation in one particular capability can have far-reaching effects throughout the rest of your capability hierarchy.
One change triggers many others.
Right. He explained how a change propagates up the hierarchy. Higher order capabilities like strategic planning or creative problem solving reorganize themselves to take special advantage of the new improvement lower down.
Okay, makes sense.
But it also propagates down. New high-level capabilities can make previously unusable or latent capabilities in the lower levels suddenly usable or even necessary. It creates this virtuous cycle, a self-reinforcing feedback loop.
He called this regenerative interaction.
Right, that's the term. A significant improvement in, say, symbol structure manipulation, maybe through much better artifacts like advanced AI models today, should enable improvement in our concept and mental structure manipulations, which in turn can enable the organization and execution of symbol manipulation processes of even increased power.
It's a self-improving, amplifying feedback loop.
Think of it like a flywheel, a small push, an initial improvement in our tools, maybe an AI that summarizes research well, gets it turning. That slight motion then makes it easier for humans to process more information, allowing for greater improvements in how we think, form concepts, approach work.
And those improved ways of thinking.
Enable us to build even better tools. Perhaps AI that generates code more efficiently, or designs new AI architectures, which makes the flywheel spin even faster. It's a self-sustaining cycle of amplified progress.
This sounds like how AI could really accelerate human evolution, intellectually speaking.
That's the potential Engelbart saw, leading to capabilities beyond our present capabilities to use and thus never developed. We're potentially talking about unlocking intellectual potential we don't even know we have yet.
Wow. Now, Engelbart also used a powerful analogy for the mental burden of complex work, the executive superstructure.
Yeah, a vivid analogy. He likened it to a mountain of white-collar talent that sits atop and controls the talents of the workers. It paints a clear picture of cognitive load.
The management overhead in our own heads.
Pretty much. He described it as a network of contractors and subcontractors, where each capability in our repertoire acts like an independent contractor, doing its own planning, specifying, subcontracting, supervising. The human, in complex situations, is juggling many roles simultaneously: policymaker, goal setter, supervisor, scheduler, specialist, clerk.
It's exhausting just thinking about it.
It is. And the problem, he noted, is that while necessary, this superstructure is a significant burden especially for multi-pass fashion or cut-and-try problem-solving, where plans keep shifting as our understanding grows. This means a great deal of extra work just in the superstructure, the planning, coordinating, reevaluating, rather than the core intellectual task.
It's the meta work that bogs us down.
Exactly. And what's fascinating is his insight that there would be significant gains from automating the HLAM system if a computer could do nothing more than increase the effectiveness of the executive processes.
So even if AI didn't do the real work, just managing the workflow would be huge.
Huge. If AI merely managed the management of the work scheduling, tracking, coordinating it, would free up immense amounts of human time, energy, and productive thought for the direct contributions, allowing them to be coordinated more effectively.
And here's where it gets really interesting, right? The insight about disorderly processes.
Yes, this is a truly profound insight into human creativity. He highlighted the freedom of disorderly processes. He observed that our existing means of composing and working with symbol structures penalize disorderly processes very heavily.
Meaning our tools force us to be neat and tidy.
Often, yes. But our natural way of thinking with new comprehension, new insights, and new intuitive flashes of possible explanations or solutions doesn't always follow a neat linear path. We jump around, connect disparate ideas, have aha moments that defy logical steps. But our tools often force us into rigid structures that punish that kind of exploration.
I can see that. Trying to capture a sudden idea can break your flow if the system is too rigid.
This is critical. The real promise in the automated HLAMT systems of tomorrow, he said, is that the human can have the freedom and power of disorderly processes without being penalized. Imagine that architect having a sudden intuitive flash about a structural element. In a manual system, documenting it, integrating it, reevaluating everything else is a huge, punishing effort.
It might even discourage the flash in the first place.
Exactly. But with an augmented system, the AI can provide the bookkeeping, tracking changes, interdependencies, implications allowing for sure and steady growth of comprehension, even when the path isn't straightforward. It lets the human mind chase that disorderly flash of genius without fear of losing coherence or creating an unmanageable mess.
So AI handles the structural complexity, freeing the human for the intuitive leap.
Precisely. This vision applies directly to AI's potential in intelligent workflow automation, dynamic project management, advanced cognitive assistance. AI can drastically reduce the burden of those executive tasks, freeing humans for higher level, creative, and yes, even beautifully disorderly work.
So the goal shouldn't be just AI for orderly processes, but AI that facilitates the messy, nonlinear human thought process.
That's paramount. Designing AI to accommodate, track, manage, and even facilitate that exploratory thinking is key to unlocking new levels of creativity and problem-solving in complex domains. AI provides the structure that allows human intuition to roam free.
Okay, so if we're going to build these incredible systems, these intelligence amplifiers, how did Engelbart suggest we approach the research and development? He introduced this dichotomy, the user system and the service system. Feels very modern.
It absolutely does. He clearly defined these two subsystems within the whole main computer system.
Yeah.
The service system is what provides the raw computer service at the interface, things like storage, access times, processing speed, display flexibility, command languages. It's the underlying tech infrastructure and software.
The engine room, sort of?
Kind of. And then the user system is the human, but crucially the human augmented by language, artifacts, methodology, and training, the whole HLANT package.
And the relationship between them.
His core principle was crystal clear and really foundational for user-centric design today. The only valid objective of a service system would seem to be to increase that user system effectiveness. The tech exists solely to serve and enhance the augmented human, period.
But he noted a challenge here, right? Evaluating new tech before people have used it.
Yes, a significant challenge. Determining the value to the user of new computer facilities, like those fast, flexible CRT displays he was advocating for before they've been properly integrated into a coordinated and practiced way of working.
It's hard to imagine the benefit of something totally new.
Exactly. He observed that users might initially predict that he would have no use for such a facility, but until he appreciates from experience what it was like to have the added capability, his evaluation would be premature. You don't know what you're missing until you try it.
This framework feels vital for current AI development and adoption.
It really is.
Yeah.
It guides AI design to be fundamentally user-centric, prioritizing how AI truly enhances human work and problem-solving within specific workflows. It implies that AI's true value emerges not just from its raw technical specs, speed, accuracy, but from how seamlessly it integrates into and actually reshapes human work methods, enabling entirely new ways of thinking.
So it underscores the need for practical user experience iteration.
Absolutely. Iterative design, real-world testing. We need to let users experience augmented intelligence for its true value to be revealed and unlocked, rather than relying on abstract predictions about what users think they need. Think about early skepticism towards smartphones, or the internet people couldn't articulate why they needed them until they lived the augmented capability.
Makes sense. So with that user focus in mind, Engelbart made a very strategic choice about whom to augment first in his research. Who was it?
Computer programmers themselves.
Augmenting the augmenters. Seems a bit meta.
It was a brilliant meta move, and for several compelling reasons. First, programmers obviously work on many complex problems, making them ideal subjects. Second, their work as highly formalizable code is inherently structured, making it easier to represent in a semantic form for computer help.
Easier for the computer to understand and manipulate.
Right. Third, their effectiveness is measured more easily. As he pointed out, few complex solutions besides a program can so easily be given the rigorous test. Does it actually work? Does it compile and run correctly?
Right.
Fourth, their normal work involves constant computer interaction, providing a natural research environment. You're not forcing a new tool into an unnatural setting. Fifth, programming involves very challenging types of intellectual effort, a great testbed for the whole augmentation hypothesis. If you can meaningfully augment a programmer, you can probably augment almost anyone doing complex knowledge work.
Okay, any more reasons?
Yes. Sixth, successful programming tools directly benefit society by enabling better software overall. And seventh, crucially, this was the bootstrapping element. Successes can be utilized within the augmentation research program itself to improve the researcher's own effectiveness.
A self-improving research loop from day one.
Exactly.
How does that strategic thinking apply to AI development today?
Directly. Focusing AI on assisting AI developers, researchers, engineers. Think AI for code generation, like GitHub Copilot, AI for debugging, testing, documentation, even AI analyzing research papers to inform new models creates that same powerful positive feedback loop.
Using AI to build better AI.
Right. This internal application of AI for AI development accelerates the entire field's progress. It's a self-improving system that builds on its own successes, pushing the boundaries faster and more effectively.
This leads right into his experimental approach and this concept of bootstrapping.
Yes, the bootstrapping technique was central. He recommended researchers begin by developing means that augment their own programming capability, starting simple and working up through a hierarchy of capabilities towards full computer programming.
Building the tools they need as they go.
Precisely. It allowed the embryonic and freewheeling art of doing augmentation research to grow and work out its kinks through a succession of increasingly complex system problems. The output of their research, improved augmentation tools, became their input, improving the tools for their own research.
It's like building the plane while you're flying it, then using the improvements to build an even better plane next.
That's a great analogy. It's a continuous self-improving cycle, driven by practical needs encountered during the research itself.
Did he have an early example of this in his own work?
He did. His Z-code system for offline text composition, which he actually used to write much of his 1965 report. He was very candid about it, calling it both hobbled and stimulated. It wasn't perfect.
Hobbled and stimulated.
Yeah, he admitted it wasn't always smooth, it would occasionally backfire, and he felt considerable constriction in his writing flow due to its limitations. But crucially, it revealed and put into perspective in a most satisfying way various needs and possibilities.
As the limitations were actually useful.
Incredibly useful. Its limitations, like a limited reach for modifications, meaning you couldn't easily reorder large text blocks, or difficulty with tougher stretches of composition, directly highlighted the niche for improvements, specifically the need for real-time immediate recycle and display with CRT consoles, which became the next critical step. It showed them what true fluidity in symbol manipulation needed to feel like.
So this empirical, iterative, self-referential approach is fundamental for AI now, too.
Absolutely fundamental. Building AI tools that enable faster, more effective AI development creates that self-improving cycle. It emphasizes learning through practical application, continually refining AI systems based on user experience, especially when the users are the developers, and understanding that limitations and frustrations often reveal the most promising paths to future breakthroughs.
It's how AI gets better at making AI better.
in a really organic, experience-driven way.
And finally, Engelbart saw a profound impact on collaboration, didn't he? Amplified collective intelligence.
Oh, absolutely. He observed a phenomenal boost in group effectiveness over any previous form of cooperation we have experienced when several augmented individuals worked together from network stations. This wasn't just a slight improvement. He saw it as a qualitative leap.
How did it work?
He explained how they could literally all work on the same symbol structure, the same document or design simultaneously, duplicating, reshaping material within that shared digital space, easily merging contributions without endless version control nightmares.
Real-time shared document collaboration way back then.
Exactly. The team could join forces at a moment's notice to tackle stubborn little problems or make group decisions, seamlessly flowing between individual work and highly integrated collaboration.
What about disagreements? Did the system help there?
Fascinatingly, yes. He talks about the natural resolution of contention. He noted that most points of contention are resolved quite naturally over a period of time as the developing structure of argument bears out one or the other or neither stand. Individuals could append objections or arguments directly into the shared structure, making disagreements visible and allowing the evolving knowledge structure itself to help resolve them.
So the shared work becomes the objective mediator, almost.
In a sense, yes. Rather than relying solely on meetings or politics, he was also really excited about multidisciplinary teams.
How did augmentation help them?
It significantly reduced the barrier that their different terminologies used to represent. Specialists could work out little shifts in meaning and use right there at their concept and terminology interface, allowing for precise cross-understanding. Imagine a scientist and an artist, or an engineer and a marketer, working on the same digital canvas, their specialized languages bridged by the shared dynamic symbol structure.
Breaking down silos.
Radically.
Yeah.
And this led to true synergistic amplification. He underscored the dramatic effect. 3 people working together in this augmented mode seem to be more than 3 times as effective, as is one augmented person working alone, and perhaps 10 times as effective as 3 similar men working together without this computer-based augmentation.
10 times. That's not marginal.
That's a radical transformation of collective problem-solving capability. The shared information, the real-time collaboration, the ability to jump between ideas and merge them seamlessly, it creates a kind of cognitive superorganism.
This is a powerful vision for how AI can transform collaborative work today.
Absolutely. AI platforms can serve as these common symbol structures, facilitating shared understanding across diverse fields, managing complex project interdependencies, enabling parallel contributions that merge coherently. Think about AI summarizing ongoing discussions, identifying themes from disparate inputs, even suggesting connections between different team members' work.
AI as the ultimate mediator and amplifier for collective human intelligence.
Exactly. Breaking down communication and conceptual barriers to foster genuine synergy and unprecedented problem-solving capability in teams. It's about building a collective brain that's far more powerful than the sum of its parts, allowing us to tackle ever more complex problems at an accelerated pace. This isn't just about efficiency, it's potentially about unlocking entirely new modes of collective thought. #outro.
So what does all of this mean for us today? Douglas Engelbart, writing way back in the 1960s, didn't just offer, abstract speculation.
Not at all.
He gave us a meticulously designed blueprint, really, a conceptual framework for understanding and building truly effective human-AI collaboration. His foundational ideas lay the groundwork for understanding what it means to go beyond simple automation to genuine intellectual augmentation. That partnership where the human mind and the machine work in that synergistic dance he envisioned.
He really provided the conceptual scaffolding for a future that is rapidly and almost uncannily becoming our present.
And connecting back to that neo-Worfian idea, Engelbart suggested the very tools we use to manipulate symbols directly affect how we think, how we communicate, the language we use.
It's a profound influence, isn't it? Perhaps the most significant one we rarely stop to consider. So as we continue to deepen our partnership with ever more sophisticated artificial intelligence technologies, the ultimate automated external symbol manipulation system, what comes next?
Yeah, what new forms of human intellect, what new modes of creativity, what entirely new levels of collective problem solving might emerge from this coevolution?
And what responsibilities does this profound influence place upon us? How we design, how we develop, how we integrate these incredibly powerful AI systems into the very fabric of our way of life, as he put it.
It's not just about making smarter machines, is it?
No, It's about consciously shaping the future of human cognition itself. It's a question for all of us, really, to ponder as we continue this journey into augmentation.
Definitely food for thought. Thank you for joining us on this deep dive into the visionary mind of Douglas Engelbart.
It was a pleasure. Absolutely fascinating stuff.
Until next time, keep digging.